amidst your busy schedule, you are here with us today, and it's really great to be with you here. Hope you have a great session today. Over to MOC.
A gracious morning to one and all present here for the Alumni Webinar Series 2020. A cheerful morning to one and all gathered here for this wonderful Alumni Webinar Series 2020 organized by Department of ECE, K.S. Rangasamy College of Technology. Happily invite our founder chairman, line Dr. K.S. Rangasamy, MJF, our vice chairman, Mr. R. Srinivasan, and Dr. Vice Chairman, Mr. R. Srinivasan, and Dr. K. Tyagaraja, CEO, KSR Institute of Technology. I heartily invite our beloved principal, Dr. R. Gopalakrishnan, KSR Technology. Kindly invite Dr. K.B. Jayanti, our ever supportive head of Department, Electronics and Communication Engineering. I delightfully invite our guest speaker for today's session, Mr. Balakumar Chinnusamy, Vice President, HR, VVDN Technologies. I cheerfully welcome all the faculty members who made this webinar series. Last but not least, I happily invite all my fellow classmates for this webinar series. Finally, I heartily invite all the students from various other colleges for this webinar meeting. Once again, on behalf of the students, I thank all the faculty members for organizing this enlightening webinar series to enrich you during the lockdown. Thank you.
Thank you, Sonia. Optimism is a magnet of happiness, which makes the people surrounded by a positive thought, good things, and good people. I call upon Ms. Keetana, final year, to introduce the man of desire, dreams, and vision. Our most valued guest, Mr. Balakumar Chinnusamy, Vice President, HR, VVDN Technologies Pvt Ltd.
Good morning to everyone. I take it as a great honor to introduce Mr. Balakumar Chinnusamy, who was an alumni of the 1999 to 2003 batch. He started his career off in 2004 by joining AU Pulse as an embedded trainer for students. From that, he went to GDA Tech India as a software engineer in the year 2005. Later on, from 2006 to 2008, he was working at GDA USA as a senior software engineer. He joined at VVDN Technologies as the tech lead in 2008. From that, he went on became the director of engineer at VVDN Technologies, followed up by business unit at networking and Wi-Fi at VVDN Technologies. He is currently Vice President of Engineer at VVDN Technologies. On behalf of Marathonist Gathering, I consider it as privilege and honor to welcome you, sir. Thank you.
Thank you.
Mr. Balakumar, over to you. The session is open.
Okay, ma'am. Yeah. So let me share my screen. You able to see? You're able to see my screen, ma'am?
Yes, Mr. Balakumar, we are able to see.
Yeah. So before going into the session, so I was introduced as a Vice President HR. I'm taking care of HR activities as a founder of this organization, right? But I'm still an engineer, right? I'm very much an engineer, and I'm proud to be an engineer for longer time, right? So let me clarify that very much. So today we are going to discuss on what is the current trend, right? So what we are trying to do here, what your institution is trying to do, or what I am trying to do, right? When people are going to certain height, their visibility increases, right? So as I am sitting somewhere else after 15 years, I'm sitting somewhere else in a different height. I will be able to see things in a better view. I will be able to know like what is going to happen in another 5 years, another 6 years, we know the trend basically, right? So that's what institution is trying to do, bring people like us to you to explain what is happening in the industry, right? What is the vision, right? Where you need to focus, right? What is current trend happening in the industry? So that this session, it would have been better I am in person in the college and explaining this, so that it would have been more interactive. I would have shown a lot of demos also to you. Sure, we will do that in some time when the COVID situations are settled, right? Right now, this session I'm going to explain what is the current trend, right? I'm going to take a little bit of time to explain why I am explaining this, and why I'm taking this, how eligible the VVDN company is to explain this to this the current trend in this market, right? So, I mean, this is the agenda. So this was explained by one of your friend, right? She clearly explained what I was doing, right? So out of this, right, designations are changing and other things are happening. But one thing was very consistent in my career throughout: learning never stopped, right? So I was learning when I was in AUPers also. I am learning now also, right? That is something you cannot stop. If you, the only way of growing successful is keep learning, right? You know this, right? Stagnant water, running water, all those things should have heard in your life multiple times, right? So you need to keep learning something, right? What next, what next, what next, right? Otherwise you will become stagnant, right? Throughout my career I was keep on learning something. The good thing in the industry is you don't have to put extra effort to learn, right? The new technologies are, you just need to be in the right seat. That's it. If you are in the right company, the technology is going to keep changing. The need is going to keep changing the society. To solve the needs, technology is going to change. If the technology changes, someone has to solve the problem. It's going to come to the engineers, and you are obviously going to learn. So just you need to make sure you are in the right seat when you are doing it. I mean, when I mean right seat, I don't mean the monetary benefits. Money can be earned at a later stage, right? Whatever the growth you do in first 2 3 years in the industry, that is going to take you for a longer career, right? My bigger growth was here in the AUPRS. Whatever I learned 6 months in this place, right? Anano city. This is inside the Anano city. I was learning there, and I was teaching people also on the embedded side. Whatever I learned there, right, that turned my life into a greater extent, right? Of course, KSR has made a given a solid base, right? I was participating in, I mean, other than technical side, I always tell my colleagues, I always tell my, whenever I go to any meetings, I always tell this, right? I learned a lot of management skills from KSR, right? I used to conduct a lot of events. I used to participate in a lot of events. I have learned a lot of management skills from KSR. I'm very proud to say that. So only thing was I was like not in the class in the final year for most of the time, right? I will be logging for the first couple of hours, and then I will be focusing on this. But that also helped, right? That also helped me a lot in the career. Whatever you do with full heart, right? That's what I will say, right? Otherwise, this designation changes are something which is not going to. It's going to happen in everyone's life, right? Yeah. So moving forward. So this is a little brief about what is VVDN, right? So VVDN as a company, it started in 2007 as a small company with 4 people. Just 4 people, 5 people started this company in India, right? Right now, I mean, our main focus is embedded system, right? We are working on most of our products are related to embedded. Some softwares plus hardware, plus FPGA, and we have some cloud solutions, right? Cloud solutions again for not a pure software, it's for embedded software. That is our focus, right? Throughout the 13 years, 14 years, this was our focus, right? Right now you can see the spread of VVDN in India, right? 4 people believed that India can do much better in engineering services than outside on the embedded side, right? Not only the application software, right? Electronics as a huge market. If you take China, if you take US, lot of companies, big companies are there based out of electronics, right? Not pure software, right? Our India culture, how we grown, right? How we grown our IT industry. Most of our focus was on the pure software, right? Our big companies, you take any big companies which has grown in last 10 years, right? They are all mostly pure software, right? A little bit of hardware and pure software. But VVDN is little different. VVDN started as a hardware company. VVDN is continuing as a hardware company. VVDN is now a ODM. I will explain what is ODM. So this is our spread in India. This is our spread worldwide, right? So we are the biggest ODM in India. So I am very proudly, I will say that we are the biggest and the fastest growing ODM in India. I will explain what is ODM. So I feel yeah. So this slide again explains a little bit of VVDN. Let's not go into the history, right? Let's focus on the key point, right? You can see these 5 verticals here, right? These are the 5 industry verticals our company is focusing on, or I will say most of the industry is focusing on, right? I mean, we are not too different from the other embedded industries, right? So this is the key area, right? What is 5G and data center? These are infrastructure related, right? Like every time you want a better mobile, you want a better speed, you want, I mean, when you click, you want the download to happen, right? That is the human need. That is the society need. You want to have a big television, 4K video has to stream in like 2000 houses in a society, right? How all those things are made possible, right? There is some infrastructure work going on in the industry, right? Maybe as a as a 5G, as a wireless infrastructure, as an internet infrastructure, as a data center infrastructure, these things are happening, right? So everybody would have familiarized with all this Amazon Prime, whatnot, right? Like a lot of such things are there, right? Even Sun TV has a solution, video hosting solution. So all those things are happening somewhere in some place in a data center, right? Data center is growing big, and 5G is the coming technology. It's already proven. It's just yet to reach the market in a full-fledged, right? A lot of test trials and things are happening, right? Again, 5G is going to bring a very big difference in the industry from the older technology. It's going to be much more faster. It's going to be much more flexible, right? So this is infrastructure. I will explain a little more in detail later, right? And then vision. Vision is nothing but your cameras, right? So this is a separate segment. Now, I mean, every one of you know that even for a small theft in your road, in a society, right? Police is also demanding, do you have a CCTV camera, right? Now, where industry has gone now, so CCTV camera is nothing like just making a small thing, right? CCTV camera making is not a challenge anymore, right? People have done multiple different type of CCTV cameras, rotating, tracking, right? And with a different resolution, right? All those things, motion detection, everything is done now. Now where the industry is going, right? So people are, how many cameras were there earlier? 10, let's take a small building complex, right? There might be like one camera at the gate. There could be one security who is monitoring that camera, which is easy, right? The security can monitor. Later it became 10 cameras. Like later it became every block, every building, every pathway started having cameras. One person cannot sit there and monitor all these things, right? And if they are monitoring, there is no use in keeping camera. Camera will find you only things after the incident happened, right? It will not prevent or it will not alarm when the incident is happening, right? So now people are focusing towards the AIML. I hope everybody knows what is AIML by this time. You would have heard about it a lot, and you would have read also, you would have presented paper also. AIML is a very nice topic which is picking up in the industry, artificial intelligence and machine learning, right? So how a camera becomes intelligent by itself, and when without putting a security to sit and watch and tell what is happening, right? If a camera itself can do that, right? That is where more focus is going on the industry, right? Then IoT again, I don't have to explain too much to you all, right? I mean, from a Fitbit to any devices, right? Even when fridges, washing machines, ACs are becoming wireless controlled, right? They're all coming up with apps now for all those devices, right? So that is IoT. Enabling internet on any electronic stuff is becoming IoT, right? Then again, networking and Wi-Fi structure is Wi-Fi is again coming under the infrastructure. So 5G data center or something like which is external infrastructures. Networking and Wi-Fi is some kind of internal infrastructure within the building, within your campus. You need to have a strong network. You need to have a strong Wi-Fi, right? To do all kind of communications and a lot of things, right? So that is Wi-Fi infrastructure. Even Wi-Fi is catching up with a lot of standards and speeds, right? When you started with internet, you might have known like 100M, 10M, 100M. I don't know nowadays people know about 10M. Right? There is 10M, 100M, 1000, 1G. Now it became 10G and it became like 100G, right? It's growing. It's growing in that side also, right? You know these things, right? Copper, then it went fiber, then it became wireless. Wireless standard is increasing every year. I hope everybody reads OFDMA, right? OFDMA is playing a very key role in enhancing the speed, right? So that's what is happening on the infrastructure side, on the networking. Cloud and mobile app, again, I don't have to explain too much here. This is like IoT. Everybody knows what is happening here, right? Anything is having an app now, right? People are getting rid of all these big laptop species, right? Everything is getting into a single device, mobile. For bank, you have a mobile. For shopping, you have a mobile app, right? Everything is there in a mobile app, right? How these mobile apps are getting controlled? It's somewhere there is a cloud, centralized cloud sitting there, and which is helping the mobile apps to communicate to the cloud and work, right? In later days, right, this will happen, right? Nobody will have a physical big servers in their office infrastructure, because maintaining a server and having a server space is like a huge cost, right? Now also a lot of people have buy their server space. If you want, you can just buy a server space from Amazon, and you can use it very much like your personal computer also, right? That's where industry is going on, right? So that is cloud. Cloud doesn't mean like just creating an app and doing something like buying, selling. Not that is not cloud. Cloud is again a bigger infrastructure side, right? Let's see some of the departments and verticals. What is there in the industry, right? So I will split electronics industry into two major blocks, right? One is engineering, right, which designs and develops a product, right? Second is manufacturing, right? Manufacturing is like India is at the entry level, I will say, right? India may be good in manufacturing a lot of things, but electronics, we are at the entry stage, and I mean, VVDN is one of the company which is leading the manufacturing path in India, right? I will explain it in my future slides, right? So these are multiple departments you can get on when you complete your engineering, right? So you can become a software engineer, you can become a hardware engineer, you can become a QA, right? So what is software engineer? Again, like you have embedded software, like what you are doing in your controllers, right? And you have the board support package. Board support package is nothing but your BIOS and your OS together, right? Not always you do something in your controllers, right? You will do a lot of work with processors and things like that, right? All your cameras are running Linux now. All your mobile phones are running Linux now. Linux is coming under the BSP, right? The bootloader or the BIOS for your Linux systems are U-boot, and the BSP is the complete package of the software which goes on a board, right? And then understanding of the kernel, device drivers, you add any new device to the your board, like it could be any device, right? It could be a small sensor, accelerometer, right? It could be a temperature sensor. You need to have a driver which attach the system, which attach that device to the kernel, right? So, I mean, we can go in deep into all these things. I'm not going to use this session for that. I'm going to just give you a glimpse. When I say software, these are all the different things you can do in software, right? Or you can become an expert in any one of this. Then you will become a very good software engineer, right? Again, for all these things, the basis C language, right? You should know C language 100%. You should know when you declare a variable, you should know where the variable go and sit in the RAM, right? Then only you become a good C programmer, right? If you don't know where the variable is sitting in the RAM, I will not consider you are a good C programmer, right? If you learn like that, where this variable is sitting, how the RAM is getting flushed, how the new stack is getting created, then you are a good C programmer. Then you will be able to do all these things very easily, right? Then hardware engineering. Hardware engineering is nothing but making your boards and products, the hardware products, right? Circuit design, right? Then PCB layout, realization of the circuit into the real green board, right? That is PCB layout. And then associate characterization, thermal designer, like thermal is becoming a very big challenge. That's a very good area to put focus also, right? Nowadays, you might have seen your devices are shrinking, right? Every time your device is shrinking and it's becoming more efficient, right? Shrinking and efficient means you are compressing a lot of things into a smaller space, right? You are obviously when you are going to do a much more action with a chip, right? The chip is going to become warm, right? When the chip is becoming warm, you need to have a provision to dissipate it outside, right? Any board design, any product design, right? It's going to take a lot of effort from the thermal side, how I will design my product so that the heat is transmitted. Like for example, you have a phone, like let's say if somebody design a phone which is transmitting the heat in the LCD side, right? You are not going to like the phone, right? When you keep it, it's going to be more warm. Here also the heat is dissipating, but in a different place, different space and different way, the heat is dissipating in the mobile phone. So that's what the thermal is. It's a big design area to focus, right? And then quality, right? Quality is like people are normally, there is a trend or thought process that quality means like it's a QA. I am just testing something. Right? Testing is not like going and clicking the UI button and telling yes, I click the button worked. That is not testing. Right? Testing has a different perception, different meaning, right? None of these developers will understand most of the RFCs. Like a spec is released by IEEE, let's say. Somebody is releasing a spec, right? No hardware engineer and software engineer will understand it 100% because they get a reference design from the vendor. Software gets a reference software from the vendor. So they don't have to really get in deep into the RFC and understand what is this technology. Like for example, Bluetooth, right? Let's say I'm using a TI chipset for Bluetooth. TI is going to give me a circuit diagram. This is a circuit diagram for your Bluetooth chip. So hardware engineer will use it. Software engineer will get a reference software, right? He's going to just download and use it. He might do a lot of tweaking and tuning there, but he's going to use it as such. But QA is not like that. QA has to measure each and every parameter of the Bluetooth, right? Bluetooth is performing according to the standards or not. Who will check that? That check is done by the QA. QA will be the knowledgeable person from the protocol side in a team, right? So he is going to tell, yes, this product works like a Bluetooth device, or this product doesn't work, right? So I will tell you why there is a QA required also. There is a need for the QA. If there is no QA, right, when the product goes for certification, right, a lot of things will fail in the certification. The QA ensures he reads the spec and he ensures that the device, whatever is getting developed, is within the spec. So that when you go for certification, your device passes the certification. Right? That is one area of the QA. The other bigger area, which a lot of developers will like, is the automation side. Right? One has to know, like C is there for your software engineering, Python is there for the automation side. Right? If one knows C and Python, is going to be it's going to be very easy for that person to be running in the system for a longer time. Right? Python is going to help you in a lot of automation, right? Lot of automation, lot of tool making can be done using the Python. Right? So that is this. Since you are all an electronics team, I am not going deep into the cloud and iOS, but this segment is very important. AML and analysis, right? AML analysis can be done by any means, right? You need to understand what is the trend going on in AML, right? Anything, any data collection and analyzing the data and taking a corrective measure. This is AML, right? It's not very complex, right? There are a lot of better algorithms, best algorithms people have bought in the, people have realized in the world, right? Where they have solved a solution, they've made a solution with an easier way. Right? That you need to keep learning what is happening in the AML, what is the trend going on in the AML, right? So right now I have told you three key areas: C, Python, AML. Right? These three areas you need to become strong. Right? Mechanical, it's not related to us. Right? This again a department which is very strongly growing. Right? Mechanical is going to give you the feel of the product. Right? Whatever you have, you may have a better. How people started liking iPhone, right? When the iPhone product or the first iPod, right, the small iPod came, how people started liking it, right? People started liking it because of the mechanical. It was very nice to hold. It looked very beautiful, right? That's how people started getting attracted towards the iPhone. Then they evolved, they increased the software features. They've done a lot of analysis in their software, and they deviated completely from their traditional Android and things, and they have done their own software, right? So, but mechanical is a key factor in any product, right? Even you can have a same engine in two cars, right? But you may like one car, you may not like another car, just because of the mechanical, how it look and feel, right? FPGA is again a bigger division. I'm not going into this also, right? This has all these things open, RTL. You may be having some subjects in related to FPGA, but this is also a growing division. So where FPGA will be more used, the main thing is in the data center. Like a lot of FPGAs are used in the data center. A lot of FPGA designs are used in the defense. Right? Defense is no time going to use any of the standard vendor chips. They will not buy a chip from Qualcomm. They will not buy a chip from Broadcom and use that. Right? They are going to design their own chips just to maintain the secrecy. Right? So that's where more focus is going on the FPGA. Right? Then when the other biggest stream is manufacturing. So manufacturing again has a lot of engineering work inside the manufacturing. Manufacturing is not like only like I'm just making a product, right, continuously. It's not that. So to enable the manufacturing, there are a lot of good amount of departments there, which transforms a product from the engineering desk to the manufacturing plant, right? It's a transformation, right? It's not like you made a PCB, it can be produced tomorrow, right? After making a product, that product need to go through lot of soaking, lot of test, lot of enhancements before it get into the production, right? So I will explain that why it has to be done, why that is important, what kind of engineering work is involved there, right? I think I go to the next slide. So again, I explained this 5G, vision, Internet of Things, and networking. These are the key industrial verticals, right? 5G is again an infrastructure. 5G as a technology, right? What is happening on 5G is like people are coming up with their own BTS and BSC devices, right? The devices which sits on the tower and devices which sits on the exchanges, right? The small cells, they are making the small cell devices and ensuring that there is a connectivity available on the 5G network throughout the sector, right? You need to have multiple type of devices on 5G. It's not single device. 5G is not a single device. There will be a central unit, there will be a distribution unit, then there will be an end unit, right? End node. Like, so all these nodes are getting made now, right? It's not a fully established solution. A lot of companies, big companies like Reliance and people are working on this, Sterlite, and these are the big companies which are working on the 5G side in India, right? Anyway, outside Huawei has done this already. Huawei has proven that for a lot of business reasons and commercial reasons, Huawei is kind of blocked now, right? The systems from Huawei is not going to all the countries now, right? That's where the remaining countries have started making their own solutions, right? That's where 5G focus is going on, right? Then data center. What is happening in the data center? You can read this word, right? Offloading, acceleration, right? These are two key words, right? So you have a main CPU, right? If the main CPU is going to do all the work in the server, right, it will get it will get overloaded. So people are making some kind of attachment cards to the main CPU, right, which will attach to the CPU, which will offload a lot of work from the CPU. It does the work remotely and submit back to the CPU. Right? This kind of systems are building. So that's what it is, like offloading and acceleration is happening in the. I mean, these all look like little hi-fi things, right? But what is the meaning of this? Is basically some software is offloading from the other software and doing some work and submitting it back, or some hardware is offloading the work from another hardware and doing it and submitting it back. So that's what it is, right? These are the terms you will see in the industry: offloading, acceleration, some of these things, right? A lot of FPGA work happens here. Vision. These are some of the product examples, right? IoT cameras, doorbells. Doorbells is becoming a big time thing, right? A lot of people are all moving from individual houses to apartments, right? Nobody wants to do any maintenance, right? And people don't want to do any maintenance on themselves, right? They're moving towards, at least, I mean, I'm talking about bigger markets, like where they buy these doorbells is US Australia, UK, they buy a lot of doorbells. It's India's its time, right? They will start buying. Even in India, big apartments, if you go, there are doorbells, right? I mean, I hope everybody understands what is a doorbell. I go in front of a gate, right? I press a button, it takes a video of mine and send it to you, right? You can sit anywhere in this world. You can see the video and say, yeah, this person is authorized to enter my home. Allow him, right? Then the door opens and this person goes inside. So this is a simple thing, a doorbell, right? So concept-wise, it is very simple, but it has a lot of technology challenge behind it, right? So that is this kind of products are coming up very well in the market. Then this is a very nice product, thermal camera. Uh, I hope a lot of people would have seen in Predator kind of movies, right? You put a glass, you'll be able to see some image moving, right? Thermal image moving, right? So these thermal cameras are capable of capturing something which is 6 kilometers, 7 kilometers far from the camera, right? I mean, basically this is used in security purpose and defense kind of area, right? Where it is deployed in the borders, and this can keep monitoring the border. Any movement, any thermal movement in the vicinity, it will pop up, right? It will say like there is a thermal movement, right? That is thermal camera. And AIML cameras, right? Artificial intelligence cameras, like which picks up alerts, which inform the user like there is alert, there is something going on in your home, there's something going on in your factory, right? So that is AIML camera. And even a lot of people would have heard about this. People are trying to take class attendance with camera. People are trying to take employee entry with camera using face recognition. These things are coming up, right? And then Internet of Things. Internet of Things is like this. Most of the products you may be using also. GPS tracker. GPS tracker is one of the things picking up in, at least in the school industries, right? GPS tracker is picking up a lot. There are a lot of big schools, even in India. They are making it mandatory that the kid has to have possess a GPS tracker, right? This GPS tracker is nothing but like you keep it in your bag, you keep it in anywhere in a vehicle or anywhere. It's going to just tell the location on a mobile app where this device is moving, right? It's a simple app. Like you can you can enable your GPS in the mobile, and even somebody can track you where you are moving, right? It's the same thing made with a simple device with a battery, right? Which can run for a few days. And the app will have provisions like you can make a geofencing. You can say like, okay, this particular thing cannot go beyond this limit, right? It should stay within the range, something like that, right? That is all software intelligence built on top of the hardware, right? Now, not only that, the GPS trackers are used for some consignment tracking also. Like any critical consignment is moving from one place to another place. Like there is a big shipment coming from Singapore to India, maybe over flight or over ship. You want to know where this shipment is coming. Maybe it's a costly stuff. It's coming, moving from there to here. Right? People started using a tracker there. They attach a tracker to that, and both the parties can keep tracking where it is moving. Right? So these are some of the applications of the tracker. Smart plugs. Smart plugs are like, I mean, people would have done a lot of project also with this. Like you can control your electrical equipments with these plugs, right? From sitting from anywhere, you can turn on, turn off these devices, right? That is smart plug, right? Then gateways. Lot of IoT devices has to connect to the internet, right? So all these IoT devices may not be Ethernet, or sorry, it may not be internet IP enabled. Like it may be Bluetooth, it may be Zigbee, right? They may not have a IP standard, right? So all these Bluetooth and Zigbee devices need to be carried over to the network, internet, after converting into the IP. So that work is done by the gateways. There will be one gateway in your home, right? And you have like multiple these devices, Zigbee, Bluetooth, whatnot, right? NB-IoT, lot of IoT devices are there. They all connect to this gateway. This gateway takes care of translating all this Bluetooth, Zigbee, everything into the IP standard and put it in the internet so that it reaches your mobile, right? That is the gateway, right? Smart locks, right? This humanless hotels are getting famous. Humanless lifts are getting famous nowadays, right? So you have a lock, and if you are authorized to enter into the building, you will have a code, right? You will carry the code in your mobile, right? You will have a app, right? I assume like this: I'm going to a hotel, Hotel doesn't have any receptionist. Hotel doesn't have any staff person helping me in the corridor. I goes there. If I have the authentication, I show my QR code or whatever, right? It opens the door and it guides me to the guides me to the right lift. In the lift, even when you show this, it will stop only to that floor. It will not go the above or below floor. It will just stop in the whatever floor you are authorized to go. Again, your room key also opens with that only. Right? These things are done using mobile also. Some specific QR code or Bluetooth enabled something are done. But the smart lock is becoming famous. It's reducing a lot of cost for the hotel industry and the tour industry, right? Secured phones, smart wearables everybody knows, right? Fitbit kind of things. These are becoming very famous now. Right? People are becoming health conscious. They started wearing a lot of these smartwatches to measure their heartbeat, how much they ran, how much exercise they do daily, right? These things are helping there. And then network again comes under the infrastructure, right? You have a lot of in every home, I think if you are having internet, you will have a router, right? That router comes under this division, right? You have a router. Router takes your internet from the back end and it gives some kind of Wi-Fi within your home, right? Those devices are called as routers. And you have like for a bigger building complexes like KSR kind of college facility, you want to give Wi-Fi across the campus, right? So you're going to have some outdoor mesh kind of access points, which is going to provide internet facility, right? And point to point, this is like in olden days you might have seen like people digging the road and laying cables. Even now, fiber cables are getting laid here and there, but soon this 5G is in picture and this 11AX standards are in picture. This digging and laying cables will go away, right? How? Because they are going to make a point-to-point connection. Like for example, you want to get a connection between Tirchangod and the next place, maybe Tokawadi or somewhere, right? You want to give a Wi-Fi connection between these two places. Let's say college is having a building there. You want to establish a connection. You're going to install a device in your campus. You're going to install a device in the other place, right? It's going to establish a point-to-point connection and service the bandwidth of it can go up to a gigabit bandwidth also, right? That is what this point-to-point is. It's going to be easily deployable, right? You don't have to dig anything. You just have to buy the device and install. That's it. You get a internet serviced in a far location, right? So this is coming up in a good time. India is doing a lot of such deployments. Even the BSNL also, and the private bodies also, they're doing a lot of such deployments, point-to-point deployments. This helps in expanding their network towards the rural, where they really don't have reach and they cannot dig and go through things, right? So it really helps. Yeah. So that is networking and wireless. So these are some glimpses of the products. This is access point. This is a mesh product. This is a gateway product, and these are the technologies where the Wi-Fi is going. Right, AX is the latest standard. Right, the fastest or the latest standard. Right, I mean these things you all know: Zigbee, Bluetooth, and things like this. Right, and yeah, these standards also we know very well. Right, Ethernet, PCI. Right, if you want to become excel in networking, right, you have to be master in one of this standard. Either become master in Wi-Fi. You need to first understand networking basically. What is networking? What is IP? What is a MAC? Right? How this whole entire network thing happens? How I send a mail, how it reaches other person. Right? This thing you need to understand as a concept. Then you need to understand one technology in strongly. Right? For example, this AX, right? AX is nothing. AX is basically derived from your OFDMA. OFDMA everybody reads in our subject curriculum, right? So you need to relate to this and see how OFDMA is helping AX to get a better speed. What is AC? What is AX? Right? AC has a lesser speed. AX is going to provide more speed. That's the difference. How they are given air is same, right? Air is not changing. Right? Given air is same. The media is not changing. Right? The method of transmission, how they use the entire carrier, right? How they have a parallel carrier running. This is what is enabling us to go from one speed to another speed to another speed, right? So that is what is helping. So you guys have to read what is AC, how AC is becoming X. Then you will understand this technology very easily, right? So that is, these are some of the glimpses you need to know on the networking side. This on the vision side. It's again like a lot of this. You can understand how this video streaming works, right? How the image processing happens, right? You were having a subject, right? Signal systems, DSP, right? These are some of the areas you can focus, right? And you can learn a lot of camera algorithms are there. I can quote you one example. This edge analytics, right? Edge analytics is basically it's a device which is sitting in the dashboard of a vehicle, right? And it analyzes all the four directions of the vehicle, right? It's seeing the road, it's seeing the side lanes, it is seeing the driver also. The analytics is running in the CPU itself. It's not going to cloud, somebody analyze and data comes back, right? So the analytics is happening in the edge, right? So to run the analytics in the edge, the algorithm should be so fine, so thin, right? So that it can run in a smaller CPU, right? That's where a lot of energy is going on. Lot of AML thing happens there. If driver blinks, right, it tells like driver is like little bit sleepy. It gives alert. It records the alert. It gives alert to the required people, right? And if the driver is going to the next lane, like in India, we rarely use lane rules, but in US and other countries, people are very strict on the lane rules. Right? If your vehicle is going somewhere in the middle of the lane, it gives alert. Right? It even marks a star rating to the driver. It shows like this driver, right? So that's a level of AML happening in the sensor. Yeah. IoT, again, I think I have explained a lot of devices. So this is the tracker you're seeing here. This goes in the kid's bag and it tracks where the kid is going, right? That's what it is. It can do asset tracking also. This is a smart plug, right? Sitting from anywhere, you can control a lot of things at home. This is a wearable example, right? So fitness, health monitoring. Another interesting product we have done in our company at least, right? This will, I mean, I don't have a snapshot of that. We have done a device which goes in the handle of the bat. It goes just in the top of the handle of your cricket bat, right? So what this device does, right? This device sits there, and when a batsman starts playing, practicing, right? This device is using a simple accelerometer sensor. It's not doing, it's not having any fancy camera or anything. Based on this accelerometer sensor, it is going to give him a track record saying that you are playing, you're meeting a lot of balls in your middle bat, you're doing a lot of edge, you're doing edge in this side, you're doing edge in low right, right? It's going to give a lot of statistics to him. This small device is going to give. These are kind of interesting things happening on the IoT side. Now, ODM is a big ocean, right? I don't want to give too much, but I will explain what is ODM, right? What is ODM? ODM is original design manufacturer, right? You need to understand what is OEM and ODM, right? ODM is a new concept coming inside India. You might have heard all this time about design service company, right? This is what you have heard, right? Design service, right? We are also a design service company, but we are transforming from design service company. We are transformed, I will say. We are transformed from design service to ODM, original design manufacturer. So what does a original design manufacturer do, right? He takes a product concept, he does the design, he does the engineering of the product, and then he manufactures the product also, but not in my name. Let's say, for example, VVDN is manufacturing a product. It's not, none of the product will have a VVDN stamp on it, right? It will just say made in India, right? It will not tell it's done by VVDN, right? It is going to have a customer name. That customer is called as the OEM, original equipment manufacturer, right? And ODM is the original design manufacturer, right? Like for example, if you are doing some device for Netgear as a wireless company, right? Netgear is a OEM and VVDN is a ODM. This is ODM. Manufacturing is picking up a lot in India, right? Our entire force energy is going towards. You might have seen PM telling this make in India, right? Why they are telling? Strategically, it is going to add a lot of value to the country, right? I have put these things, right? India is having a huge opportunity in front like never before. Why it is said like never before? It is analyzed the human resources availability. Human resource availability in India is humongous, right? Like no other country has this many human resources, this many engineers to execute anything. So our human resource availability is on a huge side, right? Second thing is government itself is promoting a lot of things nowadays. right? One example is Make in India, right? Government, hello, yeah, government is allowing a lot of import-export benefits. Government is giving a lot of flexibility for the manufacturing. Government is giving a lot of benefits to the employees who are involved in the manufacturing, right? It is giving a lot of benefits to the, see, because engineering is like 5 people, right? 5 people designing a product. Manufacturing is like 50 people producing the product, right? The kind of opportunity, expansion of opportunity in the manufacturing is so huge. That's why government is focusing towards the manufacturing. Second thing is India itself is a big market, right? India is a huge market, right? China is selling a lot of things in India, right? If India makes those things, right, India itself is a huge market of consumption, and US is also going to buy a lot of things from India. And mean, as example, right, whatever products VVDN making, whatever the products, some of the products I have shown you, those are all shipped to US today also, right? And there are some global conditions which is also forcing manufacturing to come to India kind of country, right? So you know the tariff problem. I don't know how many of you understand the tariff problem. To put it simple, so what US told, any product which is made in China and shipped to US is going to ask 40% tax, except iPhone. iPhone is having the tax relaxation, but other than iPhone, any product will be made in China and electronic products, and coming to US is going to pay 40% tax. So what this means, ideally, US is saying don't manufacture in China. That's what US is saying. OEMs should not manufacture in China. They should go outside China, right? So still some people are continuing in China with this 40%. Lot of people have started moving their factories outside China. They are moving to small countries, Philippines, Vietnam, Singapore, Malaysia. They are moving towards that, and India is the biggest opportunity. India is the biggest opportunity now, right? We have human resources, we have a huge amount of space, we have a supportive government. It's just few people have to think smart and start a lot of industries, right? This is what is ODM. This ODM is going to pick up a lot in India in another couple of years. ODM again, not in detail, little building blocks of the ODM. Hardware design, you guys know that, we just saw that. Software design, testing, there's a mechanical design when it comes to a product. Then there is a prototyping. I don't just make a direct product, right? I have to always make a sample, test, soak it enough, and then go for the manufacturing, right? Until the gift box. So this is our concept, right? This VVDN concept is also like idea to the gift box. Gift box is nothing but the box you get, the box in which you get the products, right? So concept to a complete product. That's what the idea is. So this is a very big picture, how the engineering and manufacturing merges and how it works. These are all different departments involved in manufacturing, right? So, this blue line, light blue line shows all this time engineering is happening. After that, the manufacturing is going to happen, right? So, each and every division has its needs for engineer, right? I'm just telling you all these things because you don't have to stuck to a job where you go and sit in office and doing some software. There is a huge opportunity outside this software, right? A lot of electronic work is happening in India already, right? That's why I'm explaining all these things. So first a concept comes, then a proposal is made, proposal is accepted. Yes, this is how I want to make this device. Then hardware design happens, which is nothing but your schematic. You're drawing the circuit diagram in a tool, right? Then the software design happens. Then the mechanical design happens. Then this is like making the layout, right? Making the physical. I hope you understand what is layout and the schematic. If not, I wish I will explain it sometime in a detailed way, right? And then software development happens. Mechanical prototyping happens, right? The costliest part, the most costliest part in a product manufacturing is the mechanical mold. Mechanical mold is the costliest part in the entire product life cycle, right? You do a mistake, simple mistake in mold, right? That's going to damage the project a lot. Like a thin airline also will have a bad feeling on the product touch and feel, right? So this is the most critical part, most costliest and critical part in the whole life cycle of the product. Now, you all know what is fabrication. Fabrication is nothing but making that green board, right? From the layout, how the green board is realized, that is fabrication. Assembly, Assembly is nothing but mounting your components on the green board, your resistor, capacitor, ICs, everything sitting on the setting it up on the green board is the assembly, right? And then board bring up, powering up the board first time and bring up and see all the interfaces are working. Right? That is board bring up. And then there is a huge QA division which takes care of all the standards, etc. testing, right? That is QA. This PTS is something very interesting, and it's more engineering work. So you make one product, like you make a one device, right? Testing the device, one person is enough. He can test in a day and say, okay, all this interface is working. Yes, this LED is glowing. The switch is, if I press the switch is working, right? The LCD is working. He can manually test that. Right? Let's say you have to produce 800, 900 such products in a day. That's when your manufacturing is going to be successful, right? When you're doing 800, 900 products in a day, manually testing it is not possible. It's next to impossible, right? So there are devices, there are systems made. I will show you some of the sample photos. There are some kind of jigs made which will test the PC, which will test the board. Like for example, you have this board, right? You have a test board which is sitting below. This test board and this board will connect, right? You have some connectivities between this board and the actual board. Actual board is called the DUT, the device under test, right? Device under test, there is a test bed. So this device under test will sit on the test bed. It will, the base board, which is going to test this board, will touch this board in multiple places and measure the voltages, right? It will test this, it will have the light sensors, it will have the push button mechanisms. It will do a lot of automatic testing, and it will qualify the board saying this board is working. So that is what the PTS does. PTS is production test setup. That is PTS. And then the important division is NPI, right? This is all engineering. This is still not manufacturing, right? NPI is new product introduction department, right? So what this does, any product you do, right? You'll take a reference schematic. You'll take a reference design which is given by vendor, and you do a design, right? So the design will work. It's 100% working, no problem. But to be successful, to be a successful product in the market, it need to be cheaper also, right? Like for example, you put some resistor, right? You put some resistor, or you're using some kind of sensor, which is like $1 cost, right? And if you're finding an equivalent cheaper resistor, which is like cheaper resistor or cheaper sensor, which is like $0.5 cost, right? That need to be identified. It can go for a less cheaper cost, and this can be replaced and tried. In a production line, this 0.5 is a huge difference. When I make 40,000 products, this 0.5 is going to be $20,000. $20,000 is a huge money. Nobody wants to lose that money, right? So for a single resistor, for single sensor, if it is going to be $20,000, you think about the whole product, which is going to have 1,000 components. So there is a engineering happens after the product prototyping is done. People spend a lot of energy in optimizing the things, whether the circuit can work with a small capacitor. Can I remove this part? Can I replace this part with a cheaper one? Whether it will still work. Optimizing the existing circuit and ensuring still the quality is maintained. That's what the NPI does. And it ensures that the product is manufacturable. Right? That is the NPI department. This is a very interesting department actually. Lot of retrospection happens there. Lot of reverse engineering happens here. Lot of learnings, lot of findings will happen here. Right? Then the pre-certification. I'll show you some of the photos. There is a lab in all the factories. Wherever factories there will be a small lab which does the pre-cert. Right? I ensure before going for a government certification, right? All your products you might have seen, right? CE, FCC, some kind of stamp will be there behind your product, saying this is qualified, this is certified. Those certificates are bought from the government, or government organizations, or government aided organizations, right? So that is a costly affair, right? Getting a certification. So you cannot directly bake the board and take it to the certification. Some pre-certification need to be done in the lab. This is again an interesting division which does a lot of interesting tests in the lab before taking it to the production. This is all what engineering does for a product. This is something which manufacturing does basically. It's like SEM is buying the components, buying all the components for the manufacturing, PCB fabrication, then assembly happens, product testing, production testing happens, product assembly happens where they keep the PCB into the box. Then product level verification will happen whether this function, I turn on this device is working. That level verification happens. And then packaging, and package is getting shipped, and then the RMA handling. RMA handling is nothing but when you return a component. When you return something, you buy a TV, if the TV has some problem, you always return it, right? So that goes to the RMA division, and they does a lot of debugging and find where is the problem. This can be spoken for an hour also, but I am just running fast so that I don't take too much time here. I mean, these are the various scopes in a ODM space where the engineer can fit themselves. So some glimpse. Okay, this is the PCB fabrication machine, which I mean, this is not our machine. VVDN doesn't own a PCB fabrication machine, but this is our own line, right? This is where your I am very curious. I was very curious when I was studying, right? Good KSR took me to some of the plant, one of the plant in Delhi, where some TV was getting manufactured. I went to a similar line, but not this big or not this, not kind of a clean room. I went to an IV. An IV happened in the KSR where we went to a TV manufacturing plant in Delhi, and we have seen how the TV is getting assembled. Right. Then now I am daily working here. Right. I'm able to see. So one end you give the PCB, you feed all the components in the multiple devices. This board gets populated with all the components and come with a printed board, like the complete board with all the components mounted. They call it as SMT lines, right? Board assembly lines. These are some of the mechanical facility. I hope we are not too interested in this. This is where the mold is done, right? And this is the PTS setup, right? So this is done for every product. Like you can see upper piece and you can see a lower piece, right? Your board, whatever the DUT, will get fitted here, right? The device under test. Your new made PCB, right, which is mounted with all the components, that will be placed here. This is having an electronic board inside this. This way, when this board is pressed against this board, it's going to make some contacts. Two boards are going to make some contacts. After the contacts is made, we are going to run some Python script, right, which is going to test the entire board and say like, okay, there are multiple voltage points in the board. All the voltage points are doing good, right? All the no ICs are getting warmed when I power up. Everything is good. This can go to the next level. Even they measure the clock. The clock is the basic of any board, right? They measure the clock and see that clock is doing at the right pulsing, right? So this interesting engineering work happens. This is a sample assembly line. Right? These are some of the assembly lines where packaging and things are happening, right? So this is the testing and validation lab, right? You can, I mean, these are few of the chambers I will show you in the next slide. You can see this EMI, EMC testing, salt spray testing, right? Thermal shock chambers, thermal chambers, right? You understand why these testings are being done, right? When I make a product, the product is not going to sit in my house, right? Product is not going to sit in my lab, right? I told you already, we are making some cameras which sit in the border, right? It's going to face typical temperatures, right? Huge high temperatures to the lowest temperatures, right? So the device need to be tested under all those circumstances before we take it to the field, right? Then the water spray test, right? Anything you make IP65, we ensure when you have a lot of phones coming up in this market, right? Waterproof. So all those kind of phones are tested with this kind of chambers, which will do a lot of water spray and ensure there is no leakage happening into the device, right? And this is like vibration testing. Any automotive product, you make a, let's say you make a, you're having a lot of in the car there is a audio system, right? So this audio system, your home audio system, if you put in the car, right, it's going to break in some time. It cannot withstand that vibration. The stuff which is put in your car, right, that would have gone through all this test, vibration test. They will ensure none of the part is flexible, loose, or they have given enough cushion to ensure vibration will not affect it. I'm just giving you an example, right? This is again an example how the different stage happens in a product. This is your bare PCB, right? Fabricated PCB, right? And this is the component mounting on the PCB, and then this is like making some shield on top of the components, right? So that this doesn't interfere between these devices. These ICs are going to emit something, right? We have to ensure this emission is not going to affect any of the discretes around it, right? So that is the shielding, and this is the mechanical, and this is how the device is getting fit. I'm just giving you a glimpse how the product assembly happens, right? So that you know different part of a product, and then the antenna is getting fit, right? Mechanical enclosure happens. This is how the product looks like. This is a Y-gig dongle, right? Wi-Fi gigabit dongle, which gets inserted in the PC, this USB port. Now, let's see what are the different departments and what are the different opportunities which industry is looking for, right? So, I mean, in a ODM space or in an electronic space, these are the different departments which I could see in this condition, right? I could see these are the different departments, right? And these are the different opportunities, right? Who can participate in these departments, right? Hardware, software, mechanical, layout, right? I mean, manufacturing, it's mostly diploma, right? Other than certification and PTAs and validations, right? Other than that, most of the things are done by the diploma and the ITA people. This gives you understanding the scope of electronics is a little bit huge than doing a software business, right? There are a lot of things to be done by electronics engineers other than doing a software, right? So with this, I am completing my session. If you have any doubt, you can ask any questions if you have.
Thank you, sir, for your enlightening words. Now the session is open for any queries. Willing student can ask your question to the speaker.
Let me start with one question, Bala.
Yes, ma'am.
Actually, when I was attending a conference recently, people were talking on edge computing.
Yeah.
Lot of papers were there on edge computing. Then I was just wondering, only now people have started about cloud computing. Clouds are being deployed, so people have started using cloud computing. And then all of a sudden, this conference was abroad. And now if people have started moving towards edge computing, in India, we start talking about and doing about cloud now. Now everybody goes again. So what actually is happening?
Yeah.
Why this is so?
It is a mixture. It's a mixture, ma'am, actually. So certain things need to be done in cloud, and certain things need to be done in edge, right? Where you need to be more reactive, right? The devices that are going to be more reactive to the situation. Like for example, you have a camera, and camera attached with some kind of alarm. It has to alarm immediately, right? It has to alarm immediately. It cannot like record the video and somebody will come and see the video tomorrow and understand there is a burglary happened, right? So that need to be done in the edge, right? Like for example, I quoted another example in my session also, right? There are cameras put in the vehicles. It need to be real time. It need to be real time. It need to be computed in the edge, right? Even in this edge computing, whatever the computation happens in the edge, all this record will happen in the cloud again. They will push all this evidence back to the cloud, right? Cloud will never go away. Cloud is always going to be there. Now the thing is, whatever they felt, it should not happen in the cloud. It should be more reactive. They're pushing it back from the cloud to the edge, right? So that edge does a lot of work, and don't push a lot of unnecessary work to the cloud. Two reasons mainly. One is it need to be reactive. Second is cloud is costly. Cloud is not cheap, right? Cloud is not at all cheap, right? You maintain some data in cloud for some time. It's going to be built. right? So people don't maintain too much data in the cloud, right? It's a costly thing. Second thing is like even the need is like that, right? You need to have things working more reactive. If it is in the edge, it's going to be more reactive. And the thing is like most of the places, people are not going for a new computer for the edge. Already there is a computer, they are trying to use the computer. Like for example, the cameras, right? The cameras were already having a CPU. It was capturing only the image. Now they are trying to add some intelligence also to that, so that every time they don't go to the cloud, right? Your camera itself can run some intelligence with its CPU capacity itself, right? But whatever the camera does, the recording will go to the cloud. As a simple example, again in the car example itself, the car is watching the driver is sleeping or not, car is watching the driver is on the lane or not. It watches all these things and it gives a reactive input to the cloud. It gives a reactive input to the driver and the owner, right? After doing all these things, it will still do a recording in the cloud. It will make sure all these are recorded in the cloud for a future insurance purpose or for future driver tracking purpose or anything, right? So it's cloud is not going away. Cloud is going to be there. Some pieces of elements from the cloud which can be pushed to the edge, which is going to help in a better way, that is getting pushed to the edge. That's what is happening.
So is it that we need the edge devices to be modified accordingly, that they are able to do certain computations?
Yes, yes. Edge devices will scale a bit, right? Which it will scale up. Like in same thing applicable to networking also. Like earlier, like if I send a mail, let's say we both are in same campus, right? We are in the same campus. We are under the same network. If I send a mail, the mail has to go to the server all the way somewhere in US, and it has to come back to your inbox, right? Now, a lot of software-defined networks are coming on, which ensures, I mean, it analyzes, it understands, okay, this both these people are there in this campus only. I don't have to take this packet all the way to the cloud. So I'm passing it on locally, right? So this kind of intelligence are happening everywhere. So edge computing is like the CPU has to scale a bit. Two things are there. The existing CPU itself can perform certain things. That is getting offloaded. CPU can be scaled also. Like for according to the purpose, CPU is also getting scaled. There is one interesting concept which was building some time back. It's not flying anywhere now. Good. A lot of these small devices sitting at in different places, like your security camera, your doorbell. You have like 20 electronic components around you, which is having a CPU, which is not doing anything, which is sitting idle. Right? People are thinking about distributing some work to those CPUs and getting it back. Right? That didn't fly so great. Right? That is still under analysis. How to distribute the work and get it back from the ideal CPUs. Right? But this is the reason for edge push. I hope I answered.
Yeah. Yeah, you answered. No, I just had a why this is. Yeah,
This is
questions, students? Mr. Kala is also there, joined today this session.
okay.
Hello sir, I am Mauli Shankar.
Yeah, more.
சார் நீங்க இன்ஸ்பெக்ஷன் பத்தி சொன்னீங்க சார். எனக்கு கொஞ்சம் ஏஓஇ பத்தி கொஞ்சம் லைட்டா தெரியும்.
ஓகே.
இப்போ குளோபலா எல்லா இஎம்எஸ் கம்பெனிலையும் ஏஓஇ தான் யூஸ் பண்றாங்களா இல்ல அதோட அட்வான்ஸ்டு இன்ஸ்பெக்ஷன் ஏதாவது இருக்கா சார்?
நீங்க எது ப்ராடக்ட் இன்ஸ்பெக்ஷன் சொல்றீங்களா?
ஆமா சார்.
ப்ராடக்ட் இன்ஸ்பெக்ஷன் வந்து இட்ஸ் மூவிங் டுவர்ட்ஸ் கேமரா. It's going towards like for one example I will tell. We were making one product for a car company. So when a car gets delivered from the factory, right, there is a check, there is multiple check, 250 checks are there for a typical car. I mean 250 angles are there where they need to test the car has no scratch, no dent, no nothing is broken in the wheel alloy or nothing is broken in the windshield, right? There is a 250 angle test is there. I mean, this was done manually earlier, right? Now this camera is replacing this kind of test, right? Camera is going to be fit, high resolution cameras are going to be fit, right? And it's going to do a visual inspection of this product automatically, and it's going to track the record, right? What is a device, so what is that car and how it is tested, right? What are the different snapshots took from the car, everything is going to be maintained. So it's moving slowly towards the camera. Even in our production line, for testing a lot of products, we have cameras. We have high resolution cameras. The product will pass through that high resolution camera. The camera, if there is a defect, right, it has a lot of algorithms to identify the defects. If it has a defect, it will identify an alarm. There is a defect in this product.
Okay, sir. Thank you, sir.
Yeah, that's why I was keep on telling camera AML is it's going in peak. Otherwise, infrastructure products are going in peak. Right? There should be the focus.
You're doing good.
Yeah, sir, I'm doing good.
So I think no. Just I had no one small thing. Thinking that India is not pioneer in manufacturing semiconductor. No, your company I know very well. Your lot of R&D things are happening. So because already related to COE and others trigger our students by involving them in R&D activities. Any input related to that?
Yes, sir.
Or being an EC student, more on semiconductor and VLSI embedded chip design thing.
Yeah, chip design is okay. Our aim in next couple of years, we are not going to go into the chip design area. Chip design we are doing, but we will not fabricate any chip. We will not go there. We will not set up any infrastructure to do that. But today also, VVDN has a bigger division, 5G and data center division, which does a lot of work in FPGA. This division is completely functioning from the Cochin, Kerala office, right? There's a huge setup which is working on FPGA and a lot of validation, a lot of RTL coding happens there, right? I mean, sometime I can bring some expert from that group to explain students what all different activities happening on the FPGA side. I can do that, sir.
Thank you, Bala.
Yeah. So this our idea, VVDN's idea is creating the complete infrastructure ecosystem within India itself. We should not be dependent on others, right? That's why we brought in the mechanical factory ourselves. We do our own mechanical design, our own mold, right? Else we are buying it from China. Always there was a delay and there was a huge cost, right? So we started making our own. Our next aim is to start with the fabrication also, PCB fabrication also ourselves.
Yeah. But one more question. Talking about industry 4.0 and all these things, because it's industry 4.0 in everywhere. You talk about manufacturing industry and everywhere. You start from development and all the lives. People are talking about industry 4.0, that too in smart way. So what is the VVDN's focus towards industry 4.0?
We had actually we had a complete division of industrial design division we had in our as a business unit, separate business unit we had. Then we realized industrial design is required across the board. It's not only for one set of products. Industrial design is applicable against lot of products. So we dismantled that division and put it into all the divisions. Like 2020 engineers are fit into all the divisions. Now any product we do, right, that is like some kind of rated, IP rated or some kind of rated, and it's equipped to do the industrial design. Like we are working with few customers who are 4.0, and we are doing some products for them, which is in that standard, right? This product goes into multiple areas. So that's what I told. We work in infrastructure, which is going outdoor. We work in infrastructure which is going indoor. We work in infrastructure that goes in the extreme conditions. Two examples I can say. One is in the borders, right? You can say Indian borders, right? We have done some devices which sits there, and we have done some devices which go into the deep ocean, right? We have done some camera which goes deep into the ocean, very deep, and it can capture some snaps and come back, right? So this all needs some kind of industrial standard design, right? That's integral part, sir. It's not a different area.
Okay. Thank you, Bala.
Hello, good morning, sir.
Yeah,
Hello.
very good. Yeah, very good morning.
I'm Anand from EC, sir.
Yeah.
Sir, it's a lot of products are developed in your company, sir. How will you test like 5G? The products are newly developed.
Yeah, so we have, okay, normally, okay, there will be physical measurement equipments, okay, the physicality of the device, whether it is transmitting in the right power, whether it is transmitting in the right wavelength, all those things. To test that, there are a lot of equipments already available, right, in the field. In the market, it's already available. There are a lot of test labs also which is equipped already to take care of the 5G testing. So that is one way of testing it. Second thing is, we need to have a child and parent kind of devices, right? You need to have a server, you need to have a client when you have to test, right? When we are developing a server, we also develop a client product, right? Or we make sure the client itself can simulate a server also, or the server itself can simulate a client also. That is how we do the development, right? We test it against our product first before going for the certification, right? When we are going for the certification, right, there again there is a government body which is going to test a lot of things and certify this thing. Your question basically is for the new developments, which is based on FPGA or something
Yes,
like
sir.
that, which is core purely developed in VVDN itself. Right? That's where this challenge will come, where you need to measure a lot of physical parameters using a lot of equipments. You need to submit a lot of parameters, checks, and things to the certification departments. But in most of the products where we are using the external chipsets, like we are using Qualcomm, we are using Broadcom chipsets, there this challenge is not there. Their chips are already certified. We are just going to use it. We are going to do little remodeling around that, and we are going to use that, right? So there the certification challenge is very less. But if you are going for a new chipset, of course, there is a big infrastructure of lab required, right? Which for 5G we are developing now. Our lab infrastructure is in development now, right? We cannot do. We don't have a big 5G infrastructure lab already. It was not possible last year, right? Things are coming up this year only, right? So we are in a progress of making the big lab for 5G, but till the time we are going to test it against our device itself. That's again a simple example. If you have to tell, when Qualcomm is releasing a Wi-Fi chipset, right? How they test it? That's a new standard chipset. Let's say the AX is the latest standard. When they are releasing some chipset in AX standard, what they do is also same. The same chip will be acting as a access point also. The same chip can act as a client also, right? They test it against that, and they release the chipset, right? And then they go for the certification. That's how it is done. It's a challenge area. It's not already cooked food available in the plate you can easily consume. You have to cook now. Right?
Thank you, sir.
Yeah, yeah.
Good morning, sir. I am Nivedita.
Yeah, anyway. Hello. Hello.
Hello, sir.
Yeah.
I am Nivedita from VC department, sir.
Yes.
So, what's the biggest risk involved in IoT with security level, sir? For example, if we take a device card, if the program or corrupted by someone, there may be security level issues. How we can ensure that our device is secure?
Okay. Okay. How to avoid someone reprogramming your devices? That's what you're asking.
Yes, yes, sir.
So nowadays, right, all these chipsets are coming up with some secure boot. You can read the topic secure boot. Secure boot is a topic, right? So what people are doing, they will have an image signature, right? Unless it is your image, the board will not boot, right? The board will not get upgraded even, right? If you find a way, you hack and you find a way to upgrade it, it won't boot. There is something called trust zone, TZ, trust zone. Trust zone is an area in the chipset. Most of the chipsets are coming up with this trust zone and secure boot concept, right? Because people are taking the devices from, like, I know one of my friend bought the PS2 system from the market, and he installed Linux in that, and he is using for some other purpose, right? So this can be done, right? Now what people are doing is they are coming up, the chipset vendors are coming up with something called secure boot and trust zone kind of thing. Your images will have signatures, right? The IC itself will have a signature, right? IC, when it is coming out, will have a signature, one-time programmable signature. In the manufacturing plant, they will program it one time. That one-time programmed signature can accept only one type of bootloader, right? Whatever the first image which runs on your chipset, right? It will accept only that signed bootloader. If you change that, the chip is useless. You have to just throw that chip away, right? So that is the secured boot, right? Then the secured bootloader will also have a signature. It will check before booting any OS or before booting any bigger software. It is going to validate the signature is proper. Then only it's going to boot. This is one level of security. People are going towards secured phone also. Secured phone is, I mean, it's not used in all the market. It's a very niche segment. People are using secured phone, right? I mean, blockchain. You can read about blockchain, right? Blockchain technology. Right? So a lot of security things happens on those phones also. That is how it is done. The area to be you need to read is blockchain technology, secured boot, how secured boot works, how blockchain works. These are some area you can read.
Thank you, Bala. Any more questions from the students? Any questions?
No, this I think if you have done in phase, right, there will be a lot more discussions. Yeah, this through remote.
Yeah. Now everybody is sitting in their own places.
Yeah.
Okay.
Yeah. I hope.
Okay then. Yeah. Yes, Mr. Balakumar.
Yeah, I said I hope the session was useful, right? At least some information you might have got more than what you know, right? That is more important, right? End of the day, I conveyed something. Yeah. So I'm open. When I am very much open to conduct a session on 5G, right? Whenever things are settled, I need to bring someone from Kochi who can help 5G session. We'll do that.
Yeah, definitely we'll do that. Now, even if you are unable to come also, we can do it once the college starts, all these things having come up online. We'll definitely do it, Mr. Balakumar.
Yes, ma'am. Yes, ma'am.
And it was not little information. I think every slide has had lot of information which we have to really go through. And I felt so. Every slide had information which we have to sit at least for a day and explore so that we get the terms, each of the terms, get into it and know about it. That's how it was there. So a lot of information. I think all those students who want to really get into placement can work on those points and start learning. So we'll know what's happening in hardware. You have put them all together in the slides. That's really good.
Yeah.
Anybody has questions?
Good morning, sir. Myself Aishwarya from ECE final year.
Yeah, very good morning. Yeah.
Sir, can you please give a brief about cloud connectivity and mesh networking, sir?
Cloud connectivity and mesh networking, they are little related, but not too much related. Mesh networking is basically like it's a in a way, right, multipath system. Mesh is nothing but a multipath system, right? So let's say you have the KSR campus, right? You have installed a lot of access points around the um, I mean, if you're asking about mesh networking, right? You install a lot of devices across your campus, right?
Yes, sir.
Each device is in a way connected to nearby devices, right? It's not only connected to upstream; it is also connected to the nearby devices. Any device goes down, the second device is going to take care of that area, right? This way the mesh is formed. Mesh is formed basically. There is a root node which is connected to the internet, right? And there are multiple nodes. There are multiple nodes. All are not connected as a star topology to the in a star topology way to the central node. They are distributedly connected. Why? There is a reason, right? Wireless has its own bandwidth. The time slicing can be done in a way it can handle how many devices per. So let's say you have let's say you have like 100 as a time slice, right? You can accommodate only 10. You need minimum 10 for handling a device, that you can accommodate only 10 devices, right? But directly a central node can handle only 10 devices. Let's say there is a second node, satellite node, right? Even that satellite node has a possibility. It has used this one of its stream. 10 is already consumed. 90 is available with that. So it's going to establish one more 90 below its stream, right? When we create it, if you keep on create like a tree, right? Central node, satellite. If you create like a tree, there is a problem of single point failure. If one of your top node fails, the entire stream will fail, right? So to avoid a single point failure, what they normally do is they will do a mesh. The device will not only connect to the lower stream and upper stream, device will connect always to the adjacent devices also, right? If something goes bad, the adjacent device will take over and it will take care of the thing. This is mesh networking, right? I don't know how you related mesh networking to the cloud, right? So cloud is basically, in cloud something called cluster is there, right? Cloud has different clusters, right? Like your HDFC, let's say you have HDFC account, right? Your HDFC software, what you are using sitting in Trichangur, what I am using sitting in Pollachi may not be the same server. It will go to different server, right? When you do some operations in these servers, there is a cluster formed across, right? So whatever actions you do, that will go back to the central server. In a way, it will merge to the central server. This is clustering. This is not a mesh, basically.
Okay, sir. Thank you, sir.
Yeah.
Sir, one more question. Hello.
Yes, sir. Yeah.
Sir, will you suggest some areas to learn more?
I told you. First, you need like, okay, you need to. Okay, let's say for like example, right? Let's say you want to become a software engineer, right? Let's take for example, right? Then your strongest area should be C language and Python. C language and Python is like base, right? You need to be very strong in that, very strong in C language and Python. This is the base. On top of the base, you can focus on some of the stream. What I showed you, multiple streams. You try to become expert in one stream, right? You try to develop your expertise in one stream. Either you go towards camera vision, AIML, or you go towards networking, understand the networking things properly, and see what all different type of protocols are coming up in the networking, how devices are working, right? You can focus in this area, right? Or you can focus. Cloud is not an option for. I will never prefer EC people going towards cloud or pure software. Okay, you should always go towards some of this stream only, right? And or you can go to the IoT. When you go to IoT, how to become smart in IoT, right? IoT is it looks very small, but it's a complex thing, right? You need to run a device using battery for like 3-4 days, right? With a small cell battery. What that means? That means there should be intelligent hardware, there should be intelligent software also, right? And there should be intelligent design in the chip, right? This software, one line of code should not execute unnecessarily. If you want to save the battery, if you're running one line of code unnecessarily, also that battery you are consuming, correct? So your software should be so thin and so intelligent, it doesn't run unnecessarily anytime. It just wakes up and run for that certain amount and then it stops. That is how it need to be. That's how it need to be done. right? And that's on the IoT side. IoT side, there are multiple challenges. Battery is a challenge. The product size, smaller size is a challenge. And you have a lot of technologies there. It's not, IoT is not single focus technology. You should know Bluetooth, you should know the Zigbee, you should know a little bit of internet. You should know there is something called NB-IoT, which is coming up. NFC is there. A lot of things are there in IoT. IoT is a big basket, which has a lot of things inside that, right? Again, you don't have to be expert in all, right? That is not possible, right? That will take time. Even after 15 years, I'm not expert in Bluetooth. I know how Bluetooth works, right? But I am expert in networking. You need to choose your stream. Okay, this is the stream I want to go. I have given you awareness what all different streams are available in the market. I mean, other dimension, fourth dimension can be your FPGA or something like that, right? So these are different dimensions. Choose a stream and start focusing. You can connect with me. You can send a mail. I can tell you also what kind of things you need to follow. If you choose networking, what kind of things you need to follow. That I can guide.
Thank you so much.
Yeah.
Hello.
Yeah. Hello.
Sir, I'm Pravina from EC department second year.
Yeah, Praveen.
Sir, how to get into VVDN company?
It is tough. It is. You need to be smart. That's what I say. Right? Okay. I will procedure. If you ask me the procedure is simple. Right? I have already connected with your college. Right? Very much connected, not just connected. Right? Every time I am coming there for recruitment also. Right? VVDN is a company which will allow you to earn. It will not give you upfront good money. Okay? It will allow you to earn. You have to earn the money in company. This is what the type of company it is, right? So people see the package. They see like package like 3.2. Oh, should I join this company? There is a bigger company which gives 5. Should I join there? You can join there, right? That exposure, what VVDN will give you, right? You can see our growth in last 13 years. What is the growth? We started as 4 people. Now we are 3,300 people, right? This growth and the growth in technology also, not only in the people, the kind of technology we have inherited. We are not just doing one technology. We are the complete solution, right? Any type of products in the world we can do, right? So that is the type of company. So you can see the technical base within the company, right? So VVDN allows you to join, and you need to earn the respect. You need to earn the money in VVDN. VVDN does not encourage people sitting in bench and wasting time. This is the first philosophy of VVDN. You need to understand this. Second thing, to getting into the VVDN, there is a standard exam, not too much varied exam like we ask some crazy questions or something like that. We have a standard exam. There is a C language questions. There is a set of aptitude question, and there is a set of electronics question. Like all are basics, no fancy questions, right? You have to just clear this exam to get into the interview, right? Like this exam is happening every year. This year also we are going to come there, right? This exam is going to happen. So you have to clear this exam. Once you clear this exam, there is going to be interview. Again in the interview, lot of application oriented questions will be asked, right? And basic clarity will be asked, right? So this is what we are going to ask. We will not ask like, can you explain this algorithm in AML? We will never ask that. We will try to understand what you learned properly. That's what VVDN will ask in the interview. Right?
Okay,
so,
sir. Thank you so much.
There is no other way to interview. And surviving in VVDN is also tough. Okay, I'm telling you that. I mean, it's not tough. A real engineer will go too much. Right? I mean, it's a very transparent organization. Right? So people will see you daily what you are doing.
Hello, sir. Anand from EC once again. Sir, will you offer internship?
Anand,
Hello?
can you repeat the question?
Sir, will you offering internship for us final year?
No, that is something we need to work out. So our, I mean, I have explained how VVDN works to your TPOs, right? I mean, you can connect with them. I mean, they can connect with us, and we can explain that in a better way. So our belief is that when we onboard a person in our June month, right? That person is ready, completely ready, fully armed to start his work. This is what we, as a company, we expect, right? We don't want to. We have a training curriculum for 3-4 months, but we want to start that curriculum somewhere in the Jan month and train them for 3-4 months. And when the June, when they are joining us, I mean, they need to be fully equipped. They won't they start in the action, right? So that is what we want, right? I mean, you can call it as an internship, you can call it as offered and training, however you call it as, right? So this is what we are intending to do, right? If you are selected, this is what is going to happen.
Okay, sir.
Yeah.
Good morning, sir.
Very good morning.
Sir, this is Ravina from EC department.
Okay.
So it said that FPGA is used in different purpose. May I know some of the products which are manufactured using this FPGA?
There could be a lot of products which I may not be able to even disclose, right? See, I will tell you the reason why they use FPGA, right? I mean, even they want to make a small clock, right? They will not try to use any regular IC just for their safety purpose. If they want to make a small PC, they will not buy an Intel PC, right? They will do something little different. They will not run a Linux OS. They will try to run a different OS. This all to ensure their secrecy is maintained. This is what they do. Like there's no specific product which they do with using the FPGA. They have a lot of defense products. Like your devices, your Wi-Fi devices are able to reach certain range, right? Which is government regulated and it's allowed to go to certain range. They will have. I'm just giving you an example. They will have some certain devices under same protocol which can go for a longer range because they are allowed to go for longer range, which your regular chipsets will not support. You buy a chipset from Qualcomm, this is not going to support you that longer range things. Obviously, you need to go for additional design to ensure you are able to reach that longer ranges. This is an example why they will go for a different type of device. Any device you take, they will prefer to use something. I mean, at least I know we worked with the defense for some time. I know this always they prefer to use something different than the regular ones used. Not only defense, big car companies like BMW and Mercedes, right? They don't use your regular softwares. They are having their own software, right? They're having their own software. They're having their own packages. They do that way only. They will not use the regular devices.
Okay. So one more question, sir.
Yeah.
Sir, you told that in mechanical design, molding part is very critical part and it is costly. In future, whether it will change or not, any ideas regarding this, sir?
No, mold is mold, right? So mold is like, I mean, everybody would have had idli, right? That idli cooker is there. That whatever the plate is there, right, which makes idli. That is mold. Okay, that is the mold. Your idli is the product, right? So making the mold is costly always, right? So let's take a complex product. Can you show this? So this is a, let's say, I don't know whether you were able to see this product, right?
Can't.
You were able to see?
No, sir.
No,
I'm
camera has to be moved a little. Yeah.
yeah.
Yeah, little more. Yeah, that's fine.
Yeah. So this is a product which is done using the injection molding. Injection molding, right? Injection molding is nothing but we make a metal structure and we flow this plastic into the metal and it gives this shape out, right? So now this is, you can see this how smooth it is, right? It's very smooth and shiny, right? A single flaw, airline flaw in the mold, a single scratch, simple scratch I'm talking about. A simple scratch in the mold will damage the whole mold. Mold making, mold making how they use heavy metals. They don't use, like plastic has to melt and go inside the metal and it has to again detach from that and come out, right? So it's a heavy metal. It's a steel kind of metal used there. Lot of material waste will happen, right, to design a mold, right? One mold fails, the entire mold will be scrapped. A single line, extra line, there cannot be patch up in the mold. A single line, scratch line happen in the mold, you have to throw the mold, right? So mold is a very critical piece. Like you don't like a product which has like dent in the corner, scratch in the side, right? So if the mold is not proper, that's what is going to happen. So Always mold is the costliest and complex thing. It will be continuing to be. This 3D printing kind of concepts are coming up, which may not just replace this molding. Molding is a high volume thing, right? You keep like one mold, it can keep producing a lot of products in given hours. Your 3D printing will not give this effect, right? It will never give this kind of feel, right? It's only the mold will give. Maybe later, I mean, sometime down the line, the 3D printing can improve a lot and some magic can happen there. But right now, 3D printer is not a solution to replace the mold, and it's not fast also. Mold is going to be a little faster compared to the 3D printing.
So another question, sir.
Yeah.
So once again, can you explain me about IoT devices shortly, sir?
IoT devices. Even this, what I showed is a IoT device. There's a doorbell, right? You can see one push button there. You can see one camera there, right? So I don't know what, I mean, IoT is a big topic, right? I can explain for a whole day also. It could be good, like if you ask a specific question. Otherwise, in general, if you want to know what to read in IoT, you become expert in one technology. And I prefer normally you pick up the latest one, right? BT, BLE, right? Something you learn that in deep, right? So that's going to help you. And there are a lot of software protocols. How this device, how it is communicating to the cloud. There are a lot of protocols, software protocols, like MQTT is one example, right? You can read about MQTT, how the MQTT works. MQTT is nothing but a messaging system, how the messaging happens between two devices, right? You can read about that. I mean, we can keep talking about IoT for a whole day, right? You need to pick a technology. I told already, if you're choosing IoT, you choose like what you want to be expert in IoT, right? Lot of protocols are there. You pick couple of protocols and you become expert in that, and do your project aligned to that. MQTT can be realized in software also, pure software also. You can do that.
Okay, sir. Thank you, sir.
Hello.
I actually have a question. Actually, it's not a question. I need your support, Mr. Bala, on this. We
Yes.
offer an elective IoT.
Okay.
In that case, that is actually, we have a syllabus also for that. Can you help us maybe to fine tune the syllabus so that it helps
Sure.
the students in recruitment?
Yeah, sure, definitely.
Maybe I'll send you across the current syllabus,
Yes,
and we'll change it this semester. So maybe from your lecture, I can understand if they know better on the course, then they can develop on that for the placement also.
yeah, yes, ma'am. Yeah. So it's all going to be added advantage. Like if you know MQTT, I mean, just an example. If you know Bluetooth, if you say, I know Bluetooth very well, right? But when my recommendation is, if you say Bluetooth, I know, you should know really, right? It's not like I know the spelling of Bluetooth. That's not required. You know how Bluetooth works. It's simple, right? It's how you are communicating. You're using English to communicate. Like the devices use some technology to communicate, right? I mean, who is master, who is slave, right? How this protocol works, right? I mean, one has to understand, and you have to teach others also, right? How this technology works. Teaching is something nice stuff. As you teach, you will grow your knowledge also, right? So, and when you are learning something new, it is good to teach, because while learning and teaching, you learn more actually when you have to teach, right? And moreover, like a lot of
True.
curious questions will come, then you will again learn more, right? Don't learn something and keep it with yourself, right? Try to teach to others also, so that your learning will increase.
True.
Yeah.
Any questions are there, or shall we close the session? Students?
Hello, sir.
Yes. Yes.
Sir, I
Yes.
am Moli Shankar.
I think,
Yeah.
yeah.
Sir, is VVDN recruit a fresher through walk-in interview?
Yeah, we does. I mean, if colleges are not giving us enough people, we does that. We never had that situation in past. I mean, it will not be happening in a regular time frame, right? It will be happening in an odd time frame, right? Like for example, you are completing in June, right? June definitely there will not be work because already we would have worked with colleges and we would have pulled enough resources, right? So that way, in June time frame, walk-in will not happen. Let's say we find a need in, let's say, down the line in December we are finding, okay, we need immediately 50 engineers. That is the time frame when we will go for a walk-in, right? In our history, in at least in VVDN history, for fresher we have not conducted walk-in, right? But it is open, right? If you like, you can approach through your college, you can approach us, no problem. We will conduct the exam. There is no problem. I will allow you to reappear also. There is no problem for us. We need quality engineers. Our standard of questions will not change. We are going to ask the same question. See, I have the need. I have already explained all the colleges, and I think KSR also we have informed how many people we are looking for, right? You can prepare. You have time. At least it's not going to happen this month. Next month, maybe next month or next month mid or sometime it will happen. I don't know the timeline. Sorry if I'm confusing TPOs, right? So that timeline, someone will work from HR side with the TPOs, right? But you have time. You have 1 month time. More than 1 month time you have. That much I know. You can read. You can get directly placed through college itself. You don't have to worry about walking.
Okay, sir. Thank you, sir.
Yeah, yeah.
Yeah, I think we have taken much of your time, and it's already almost 11:20.
No problem.
Thanks.
Thanks.
Thanks a lot, Mr. Balakumar, for having been with us this morning with your schedule. Thank you very much for all your inputs, and we are looking forward for the recruitment process also.
Yes, ma'am.
And hope we are able to do this time. Last time we missed it. No ECE was there in VVDN. Hope we will do it this time. We wish we do it.
Yes, ma'am.
Thanks a lot, Mr. Balakumar. Thank you very much.
Thanks for the opportunity. It was nice talking to a lot of young minds. Right. Good.
Pleasure is ours.
Yes, yes.
Thank you.
Thanks everyone. Bye.
Thank you. Bye-bye.